Dear students, under the lecture series Graph Theory, here we have lecture 8. Now we are going to solve a very significant problem under graph theory. That is, we have to prove that minimum degree small delta is lesser than or equal to 2q by p lesser than or equal to capital delta, which is the maximum degree. Now let us prove this. Now in order to prove this, first we shall consider the vertex set of a graph G. So let G be a P comma Q graph. That means it has P vertices and Q edges. So how the vertex set of G will be? So vertex set of G, V of G will be equal to, we are going to take the vertices as V1, V2, V3, and we will have vertices until Vp because there are P number of vertices. So this is what we have. Now if we take any one vertex from this, and if we write the degree of that vertex, so degree of any vertex Vi, if we take from this, definitely it will be greater than or equal to the minimum degree delta, and it will be lesser than or equal to the maximum degree delta, because it should either lie between these two or it should be small delta or capital delta. If you take any vertex Vi where the value of I will be from 1, 2, etc. up to P, which means V1, V2, etc. up to Vp. So if you just write it in, like for example, if I is 1, that is delta will be lesser than or equal to degree of V1, which is lesser than or equal to capital delta. So this is one equation. Similarly, if you put I equal to 2, delta will be lesser than or equal to degree of V2, which will be lesser than or equal to capital delta. This is equation 2. If you put I is equal to 3, delta will be lesser than or equal to degree of V3 lesser than or equal to capital delta. The third equation. Like this, if we keep on giving values for I, it will go on until degree of the last vertex is V3, Vp. That will be greater than or equal to delta and lesser than or equal to capital delta, and that will be the pth equation. So you will have p number of equations of this type. Now if you sum up all the equations, that is if you add all the equations, you will be having it as degree of v1 plus degree of v2 plus degree of v3 plus etc. up to degree of vp. It is what actually summation of degree of vi for I varying from 1 to p. So p number of vertices are there, you are adding all the degrees, and that will be greater than or equal to, now here you have delta, how many times? P times, because delta here you have plus delta and plus delta. When you sum up all this, you have p times delta, so you will be having p times delta, and this will be lesser than or equal to this capital delta. When added up, for p times, when it is added up, it will be p times capital delta. So this is the inequality that we get. But what is this? By the first fundamental theorem of graph theory, we know that summation I equal to 1 to p, or vi, okay, degree of vi is equal to 2q, twice the number of edges. So this first fundamental theorem we are going to apply here. So what will happen to this? This will be p delta is lesser than or equal to 2q lesser than or equal to p into capital delta. Now what we will do? We will divide this throughout by p. So when p delta is divided by 3, you will be getting delta lesser than or equal to 2q when divided by p. So it will be 2q by p lesser than or equal to, when p delta divided by p, pp will get cancelled and you will get capital delta. So when this is divided throughout by p, this p goes off and this also goes off. Here you will get 2q by p, and therefore we have arrived at the result that we require. So therefore minimum degree is lesser than or equal to 2q by p lesser than or equal to the capital degree. Hence we have proved. So hence proved. So this is a very significant problem. So I hope you would have understood this problem. Thank you.